Thanks, Igor. Okay, so I get the fun part. I get to talk about data. I know it's not fashionable these days to deal with facts, but we do things that aren't fashionable sometimes because we're engineers. Okay, so if you just joined, I think most of you were here before. If you just joined, Michael, just right before the break, reviewed some things about the resource manager in Spark and why that's important to performance in a multi-user, multi-tenant environment, and gave a bit of an outline of a benchmark suite that IBM developed with some input from us. So who is us? I'm with a company called STAC, stands for Securities Technology Analysis Center. We facilitate something called the STAC Benchmark Council, which is out of the finance industry. It's a whole bunch of user firms and vendors that establish standard technology benchmarks based on workloads that the finance industry cares about. There are a lot of esoteric, high-performance workloads, whether it's big data, big compute, fast compute, fast data in that industry. And part of our role is to perform independent benchmark audits of those standards. Now, what we're talking about today is not one of those standards that came out of that council. We do the occasional project like this, which we think is of interest to the finance industry and in this case, a broader range of industries. But our role in this was to provide some feedback on these benchmarks based on our experience with benchmarking and inspect the system, make sure that things are set up and that the tests ran in conformance with those specifications, and inspect the system configuration, report everything, and we produced a stack report from this, which you can download. There's links in the back of this presentation to the report, and it's about 26 pages with a lot of detail, which we don't have time to go into today. So what I'm going to do is sort of take you through at a high level some of the results from this thing, and then at the end of that, Michael will come back and talk a bit about some interpretation. Why some of these results look the way they do. So I want to start with some visualizations, and just to orient you, let's see if this pointer works. Yeah, it does. Our horizontal axis here is time during the test run, and specifically it's the job start time, okay? So we're going to show you for all three resource managers that Michael mentioned, Yarn, Mesos, and IBM Spectrum Conductor with Spark, probably the longest named resource manager in the industry. We're going to show the results, and we didn't run these simultaneously. We ran them on the same cluster, but at different, one right after the other. But I'm going to show them simultaneously so you get sort of a consistent view. The job start time is on the horizontal axis. The vertical axis is the duration for the job, and on a log scale. Okay, so some of these jobs, as Michael showed, were a few seconds long if you ran them in isolation. As you'll see, sometimes they get a lot longer when you're in a multi-tenant environment. And some of them were batch jobs, k-means and so on, that were many minutes long. So to visualize that all on a consistent scale, we used a log scale here. So this is the first visualization here is use case 1. So this is the use case with interactive jobs only, okay? So the cluster is empty. On your marks, get set, go. The green dots are Mesos, the blue are Conductor, and the red are Yarn. You can see that Mesos starts out well. It has some outliers, though, up there, and it's got some trouble, but then it stabilizes. But Yarn now is experiencing some outliers, and they're racing along, and Conductor's been fairly consistent here, a few small outliers, but now Conductor is done. And Yarn and Mesos are headed for a photo finish. And finally, after about almost 3 hours, we're done with all three platforms. So you can see a few things from this. The first sort of obvious thing, again, the colors here are, the red squares are Yarn, and the green rectangles, I get my shapes correct, the green triangles are Mesos, and the blue dots are the IBM product. The IBM Conductor throughput was much higher. It finished all these jobs in significantly less time than Mesos and Yarn, which were pretty much neck and neck in this use case. Again, this is the interactive-only use case. You've got a bunch of users firing in requests, and in that ramp up, steady state, and then ramp down situation that Mikhail described. Another thing that is apparent from this chart is differences in variability. In many cases, you care about the predictability of job runtimes. You don't want one user to wait a really long time while another user is speeding through necessarily, unless that's a policy that you set. And in this case, there were no quality of service priorities set on anything. So you can see that, as we mentioned at the beginning here, Mesos had some difficulty as jobs were filling up and as users were launching lots of queries. But then it stabilized. But overall, you can see that the variation was higher for Yarn and Mesos than for Conductor. And when you look at this statistically, which we will in a moment, these big outliers have a big effect on the overall variability metrics, especially since, remember, this is a log scale. So some of these jobs were taking a second, and some of them were taking hundreds of seconds, thousands of seconds, either thousands of seconds. So if we look at that in a tabular form, in terms of throughput, the IBM Conductor had about 56% higher throughput than Yarn, and about the same, about 57% higher than Mesos, because Yarn and Mesos were nearly the same. We did 2 runs on each platform and took the worst case for each, sort of our conservative approach. So that was use case 1. That was interactive only. How about use case, forgot about variability. For variability, we took a simple metric. We looked at the standard deviation of job times for a particular query, divided that by the average job time for that query, and that gives us a relative standard deviation. And I don't remember if Mikhail went through this or not, but the queries, the queries are, these are queries from they're sort of inspired by TCP/DS. Cloudera has done some similar things where they've run queries based on TCP/DS. And these are the ones that Cloudera had grouped as interactive queries. We took just the sort of the simple average of those for each platform, and you see that the Conductor was around 71%, and Yarn was around 304, and Mesos was 777. So significantly better, lower deviation with Conductor than Yarn and Mesos, and lower with Yarn than with Mesos. Okay? All right, so what about batch jobs? So let's look at batch jobs by themselves. Same scale, same conditions. Let's let it go. So here you see, of course, all the jobs are taking longer because they're batch jobs. They're larger jobs. They're big queries from TCP/DS, or they're k-means jobs. And in terms of overall performance, there's sort of a similar order of magnitude now between the different platforms. But once again, Conductor is finished after about an hour and a half, and Yarn after about 2 hours, and Mesos after about 2.5 hours. So another big throughput difference. Just apparent in this chart. Variability differences doesn't look as extreme. Let's see if that's held out in the numbers. So throughput was for IBM was 30% higher than Yarn, 62% higher than Mesos, and Yarn was about 25% higher than Mesos in this batch-only case. In terms of variability, consistent with how it looked on the chart, the differences were smaller. The IBM was 28%, Yarn was 36%, and Mesos was 55%. So that comes out to about a 1.3x advantage in relative standard deviation of IBM versus Yarn, and 2x less than Mesos. and Yarn was about 50% lower in terms of relative standard deviation than Mesos. Okay, so that's batch only. Some of the more interesting stuff, though, is when you have a mixed workload environment. You've got, let's say you have a department that's got some users that are launching interactive queries, and you've also got some batch jobs. So the first thing we did was we looked at that and said there's no prioritization, just everybody's got access to the same cluster at the same priority. Although the pattern is that the batch jobs start, and after about 5 minutes, then you hit the thing with interactive queries, and you see how things play out. Okay, so here we go. And so you see your interactive queries coming in there, and it's starting to cause some trouble here with Yarn. Got a lot of big outliers with those red dots, and now again at about a little less than an hour and a half, Conductor's finished. Yarn finishes earlier than Mesos, but it's really got some really big job times in there, and Mesos finishes around 2.5 hours. So if you look at that in terms of numbers, the IBM throughput was 50% higher than Yarn and about 88% higher than Mesos. Yarn was a significant but not huge amount better than Mesos. So finally, the use case 4 takes that same workload pattern but imposes some business priorities and says, okay, the policy is that interactive jobs are the priority. When they happen, we want them to get the lion's share of the resources, specifically 70%. But we don't want to kill off the batch jobs completely. So batch jobs have 30% to work with when the interactive jobs are going. And when there are no interactive jobs, the batch jobs are supposed to be able to take the whole cluster. Okay? I should have mentioned ahead of time, there are a number of limitations with any study, and we try and be as open about that as possible. In the report, we document a number of the limitations, and one of them was around this use case 4. It became kind of tricky to configure this for each of the platforms, actually. Well, I'll talk about that after the results. I'm sorry, I forgot to talk about variability in use case. I keep forgetting about this. All right. Just before we go on from use case 3, so in use case 3, we've got both interactive and batch workloads, again. And so we first looked at the relative standard deviation, the average relative standard deviation for interactive workloads as a group, and then for batch workloads as a group. And then we weighted. We came up with a weighted average, which was weighted by the number of queries in that group. And overall, the weighted average was 28% for Conductor, 60% for Yarn, and this is an eye test for me because my monitor's blocked. 73%, I think it says, for Mesos. So that's a 2.1 to 2.6x advantage for IBM again. Okay. All right. Now we're to use case 4. This is the one with some quality of service constraints in it. And you're going to notice that the scale is a little bit longer, actually a lot longer in this one, and the reason for that will be apparent in just a moment. So let's go here. So we've got some big outliers already. The interactives are playing, and now the interactives are done, and the batch workloads get the resources back, and Conductor finished. Oh, thank you. That's okay. Conductor finished. Mesos finished a bit later, and now Yarn is still chugging along on these batch workloads. In fact, I think the scale here is after the interactive jobs were done on Yarn, it took another 5 hours or something to finish all the batch workloads, and it only took it 2.5 hours to do the entire batch workload when that's all there was batch workloads. So clearly something going on with Yarn here. And Michael will talk about that a bit. But to let's see if there's anything else I was going to point out on this chart before moving along. Yeah, I mean, just in terms of job durations, the interesting thing is that they really don't change for Yarn for those batch workloads. Again, the higher ones tend to be batch jobs because they're longer running jobs on this chart. Mesos had the biggest outliers, but it did have better throughput than Yarn in this case. If you can tell, there are also very few red dots in here, which you can interpret to mean that during the period when there were a lot of interactive jobs, there were very few batch jobs getting done in Conductor. Conductor is the red ones. Whereas there's still a fairly good number of blue dots and green dots from Mesos getting done during the interactive. So just in terms of numbers, this came out with IBM was like triple the throughput of Yarn in this case and 25% higher than Mesos. And Mesos was about 2.5 times the Yarn throughput. I said I'd mentioned some limitations. One of the problems with use case 4 was each platform had some tricks to it. I mean, in the Conductor case, there was actually a bug which prevented preemption from having much effect in this case, because Conductor does have preemption capability. That bug's been fixed, but in any case, that was a pain. Yarn supports preemption. For some reason, when we enabled it, it reduced performance. So switched back, and Mesos, Mesos doesn't support preemption, and it's not necessarily actually at least the version that we use. I'm not sure about the most current version of Mesos, there isn't an exact fit to the quality of service use case, but we tried as much as possible with consultation with some people that really understand Yarn and Mesos to make a best effort to configure them optimally. In terms of variability, IBM had 2.5 times lower average RSD than Yarn, and a little bit better for Mesos, because you saw Mesos had a lot more variability, and Yarn had about 10% lower relative standard deviation than Mesos. So just to summarize, we put this in a table since in every case the IBM Conductor had an advantage. One way to visualize that is just to show what that advantage was across throughput and relative standard deviation for all 4 use cases, and that's what this table does. So this is just a summary of the numbers that I showed you before. So this is how many times better the results were when run on Conductor than run on the other things. Okay, so one of the interesting questions is why, and for that, Michael's going to come back up and talk about that a bit. Michael? Oh, it's okay, you don't have to clap yet. Oh, you don't have a mic? Oh. We have a handheld or something? Oh, there we go, okay. Oh.
Okay, can you hear me?
Yeah, it's on, go ahead.
Okay, so why, right? So to be fair,
hold the mic up to your mouth.
First of all,
hold the mic up to your mouth.
Yeah. So first of all, we don't know all the answers, right? So this was exercise in creating a benchmark, running in, and then try to see the results. We didn't go very deep into analyzing it, and basically that's why we presented it, what we want the community to do. Just we want to point that there is a very important aspect of resource management and Spark interaction with resource managers, and it needs to be investigated, and this is a tool to investigate it, right? That's the benchmark is a tool, and then You can do tuning. We not claim that this is the best tuning. So as Peter said, it was consulted with some experts on the tuning of yarn and meshes, independent from IBM, right? But this is a tool, and then we got the results, and then we're trying to understand what can be improved. So, two actually major things. One is dynamic allocation and deallocation, releasing of resources, right? So the general resource manager should allow application allocate and release resources during execution based on the demand at that moment, right? So the Spark job consists of multiple stages. In each stage, it needs different number of tasks. So that's basically a demand. So in Conductor, what we was trying to do is do fine-grain on-demand allocation. So basically, the driver, Spark driver, in this backend scheduler, we had our own version, was trying to do dynamically allocating at that stage how much it's needed. When it don't need it, for example, on the second stage, I'm doing aggregation, I need less task, right? So that's releasing it at that moment, right? With Yarn, it's look like that specifically for the use case number 4, it has problems with deallocating of, as you see in the long tail, right? After that interactive jobs was finished, the batch job basically had all the cluster, but it looked like that there was a delay in starting the batch job after that, even that interactive is gone. So there was some problem with the releasing of these resources, which was allocated for the interactive. With meshes, what we've seen is it's supporting basically dynamic allocation and release, but it's using offering mechanism, and that offering mechanism has some problem, and maybe I will go a little bit and show you some use case number 3, right? So if you look into the green dots, this is a message. So it's appear in strange patterns. You see these vertical lines, right? So as I said, we didn't do that very detailed analysis, and that's basically what community, I think, need to look at. But what we've seen in a lot of, if you look into the message logs, we see a lot of rejection of this offer. So how methods working, it's basically offering everything to the first come for that. And we've seen a lot of rejected offerings, right? And then it's basically delaying this execution, starting of execution of specific jobs, right? So that's what I mentioned there. And second important thing is a preemption, right? So in this specific case, when we starting to run one user, we add in another user and so on. So basically, first user taking all cluster, all resources, then the second user comes, so that some of the workload need to be preempted. And that can be done in many different ways. In the integration in Spark, when it's asking for such things, basically, and also mostly in Resource Manager, because basically every job is greedy trying to get as much resources as it can, but the Resource Manager, sorry, need to handle that preemption to allow this SLA, and in case number 4, you've seen that we were trying to configure it to basically give the 70% with higher priority to the interactive and 30 to batch, right? So that's preemption should allow even distribution, or not even, but based on this policy, right? And with Conductor, we also add in something we call smart or intelligent preemption, in terms that when the resource manager doing the preemption and scheduler doing the preemption part. It's also need to think what it want to preempt and to whom give this resource, right? So if it's done randomly, then it's not good as this results show. And we were trying to apply some heuristics how to do this, and it seems getting some results on that, right? If you look into the yarn, so again, we are not experts in yarn, but it looks like something is wrong because you think this case number 4 is a tail, and as Peter said, but actually it's with preemption turned off, because with preemption turned on, it was worse. The runtime was worse than with preemption turned off. And with the message for that version which we use, it was not supporting preemption at all, right? But I'm not sure if the latest version it's already started to support preemption. I'm just pointing that should be there. It's very important for evenly distributing workload, and in the end goals is to get higher utilization, right? So basically, how much you can fit in the cluster. So we would like the community to start using it. As I said, it's open source and it's in GitHub. So I was getting a few questions about how it's implemented, right? So that SMB, basically it's a bunch of scripts and Scala code. So it's all independent on any resource manager. You can use it with these resource managers. You can use it, for example, with, I got a question that somebody trying to use Kubernetes with Spark. Because what it's doing, it's using Spark Submit. And the jobs is self-standard Scala. And the metrics which we take in, it's actually not coming from any logs of the resource managers. The metrics we're writing from the inside the code. So it's completely independent on where you run it. Right? So it can be run in your cluster. You can estimate basically how well your cluster will do with your applications, with your clients, and also what need to be tuned, because there is a lot of parameters which affect. So basically, it's probably the good thing to run it multiple times with different tuning parameters and see how it's getting better. And for the developers who work in the Yarn and Messes community, I think it would be very important to use it to try to understand deeper than what we presented here, what's going on inside, why it's having a problem, and how it can be improved. So the first link, this is a GitHub where you can get this benchmark as a tool. The second one is this report, 28 pages, which Peter presented. Then we have a blog which is discussing the benchmark. It's under IBM Developer. You can post the questions if you have additional questions. And blog also has some summary of the results, which we actually was presented here. If somebody interested in the conductor itself, it has also a link to conductor, and you can look more details on the conductor. Any questions to me or to Peter?
Thank you.
Yeah, we have enough time just for a couple of questions. Please raise your hand. I'll come by with a mic.
Hi, so I have a question about how you confirm that the yarn settings you used were like optimal for this benchmark. Like, did you actually check to see if CPU, memory, like disk I/O, these things were properly optimized for your benchmark testing, or I mean, how do I know that this, like, you know, how do you know that your settings or you're doing apples to apples comparison between these?
Well, so let me start with that. First of all, to echo something Michael said, we don't consider this the last word on this stuff, right? And I have to think that there was a configuration solution somewhere in use case 4 that would have, you know, eliminated that really long tail. I mean, it looked to us like only a portion of the cluster was available after the interactive started, and that's why the batch workflows took so long. But to answer your question, basically, we reached out to the industry and hired in somebody who was very experienced with Yarn and Mesos to review configurations and so on. There was limited budget. We couldn't just let them experiment forever. The thing with tuning, as sounds like you know, is that there's really no end to it. You can always keep experimenting and trying new things. And so I think that's one of the reasons that Michael is encouraging people to grab this benchmark, run it, contribute results, and that sort of thing.
Okay, thanks.
Thanks. So it looks like we're out of time, but please feel free to come up and ask the speakers questions personally. Let's give them a round of applause.